Hello everyone. In this video I'm going to talk about delegates. Delegates are a way of passing a reference to a function in your class to other classes. So in this way you can give an access to your function to other classes without ever exposing your own class. So basically delegates are a pointer to your function. They are very useful for abstraction and loose coupling of the subsystems in your program, and they are also used frequently in other design patterns. For example, they will be used for callbacks and for the event delegate system. Both of these topics I will cover in subsequent videos. Delegates enable us to pass a reference to our function, just like we would pass a reference to a normal variable like a transform or game object. So I will first give you a very short example of passing a reference of a transform, and based on that example we'll develop it to show to how we can use delegates to pass a reference of a function. So we'll start with the same setup as our previous video. We have a game object player with the player class and an enemy with the enemy class, and what we want to do is to pass the reference of the enemy transform to the player script. So in order for the player to receive a transform reference, we first need to create a transform variable, and let's name it enemy transform. Now at first this transform would be empty, it would not hold any reference for any transform. Then what we need to do is give it a reference for any particular transform, and in this case we want to assign that variable the same transform that this enemy has. So we'll go to our player class, the transform, and to this enemy transform variable we will pass it a reference of our transform. So that would be this dot game object dot transform. So now this variable will hold a reference to the enemy transform. This is called passing the reference, and you will see later that how the same concept applies to when we are passing a reference to our function and when we are using delegate. Now there are two essential things you need for passing a reference to other scripts. The first is a type of the reference that you want to have, and second is a variable of that type which will hold that reference. So when we come to the question of passing a reference of a function, first we need a type that is going to hold that reference, and we also need a variable of that type. The delegate enables us to define that type, and then we create a variable of that type, and then we pass it a reference to our function. So how this works is that we start creating public, we use the keyword delegate, and after that we need to define the type of the function whose reference we are going to hold. And the type of a function is determined by two things: the return type of the function and the argument types of the function. So let's take a simple function as an example. Let's create a public void, a simple function which will give us a debug message when the enemy is killed. So let's say I died. Now this function is identified by its return type, which in this case is void, and it will be defined by the type of the arguments that it is going to take. So in this case this function's return type is void, it is not returning anything, and it is also not taking any arguments, so the arguments are also void. So to create a type of this function, we will write the return type. First we for defining any delegate, first we write the return type of the function, then we give a name for our delegate. So let's name it kill delegate, because it will hold a reference to the kill functions. And then we give it a list of all the arguments that the function will take, and in this case it is not going to take any function, so we can either write void or just leave that space empty. Now this creates the delegate type for this particular kind of functions. Now we still need a variable that will hold a reference to those functions, so we will create a variable of the type kill delegate. Let's name it kill delegate. Now this is the variable which is actually going to hold a reference to functions. So let's give it a reference to our function from the enemy script. So for that we will do it similar to how we assigned it our transform. So we'll go to player dot kill delegate variable, and this will now hold a reference to our kill function, and how we do that is simply write the name of our function. Now when the game plays and the start function is called, this variable will be would be filled with our a reference to our function, and the way to call that function from the player script after we have that reference is you can either just take that variable and assign two brackets to that, and this will call any function that is assigned to this delegate. There is another method to do the same thing for calling our functions, is to use the delegate name and then call the invoke function on that delegate, then it will call the referenced function. So we'll very quickly go and test working in our game. Now since we are calling that delegate on every in the update loop, so in every frame we are going and calling the kill function in our enemy script from this delegate which is in our player script. So this kill delegate which is actually calling the kill function in our enemy is called every frame. Now the first thing that you will notice by what we have seen till now is that the player script which is calling the actual kill function on the enemy script, this player script has no knowledge about the enemy script. It doesn't even know that if a enemy script exists in the project, if it has actually uh, gave me a reference to my delegate. So it is always a good practice to check if your kill delegate is not equal to null, so that if there are no functions reference for your delegate, you are not calling it calling an empty delegate. So it is a good practice right here. This leads directly to loose coupling between various game systems, so they are not directly dependent upon each other, so that if one system breaks, the other is not always going to break. This also leads to two very important points that I will show you. The first cool thing is that you can retarget the delegates in the runtime. By that I mean is that suppose you have two enemies in the scene. I made another simple setup that I have two enemies in the scene, and when the game starts, if there are two enemies, enemy 1 and enemy 2, and when the game starts, first the enemy 1 will assign its kill function to the delegate. So for the first 5 seconds of the game, player 1 will have a reference to the kill function on enemy 1, and when the 5 seconds are over, the enemy 2 will assign its delegate. So I'm using this invoke function for a delayed, and then I'm retargeting the delegate to the enemy 2 kill function. So now when we come in the game and test it, you can see that for the first 5 seconds, player is calling the kill function on enemy 1, and when the 5 seconds would be over, it starts calling the enemy 2 function. So while all this is happening, the player script which is actually calling the kill function doesn't even know that there are two enemies in the scene. It doesn't know about the retargeting. It is oblivious to that, and it still functions perfectly. So this shows you the power of how delegates can be used to make more robust systems. And the second interesting feature of the delegates is that you are not necessarily bound to assigning one single function to a delegate variable. So if I have two enemies in the scene, if I have more than two enemies in the scene, I can assign all these skill functions to the same delegate of my player. And what happens in that case is that instead of just calling a single function, whenever I am calling my kill delegate function, or if I am invoking that delegate, all the functions that are attached to that delegate will all be called. And the simple method to assign multiple methods to the same delegate is to use the plus equal to operator instead of the equal to operator. So rather than writing player dot kill delegate equal to the kill function, we would write kill delegate plus equal to kill function. So this will add our function to the list of already assigned functions to that delegate. This way, when we have multiple number of enemies, where all those enemies want to hook their functions to the delegate, they all can do so. Now if we come to the scene and test our system, so let's pause the game and check out the output. So on every update, the player the player delegate is called, and it calls all the kill functions that are attached to that delegate. So in this case, it first calls the third enemy, then the second, and the first. The order really doesn't matter because the order depends upon which start function is called first and which is not directly in our control. So but it will call all the kill functions on all the three enemies that have used the plus equal to operator to subscribe their kill function to that delegate. So it calls 321, again 321, and then goes on calling all those kill functions. When you are using the plus equal to operator to hook your function to the delegate, and if you are using the event system, this process is called subscribing to that event, or in this case the delegate. So if you are subscribing to that delegate, you should remember to unsubscribe from that delegate, because it may happen that your enemy game object is destroyed and the mono behavior is destroyed, but the delegate doesn't know about the destruction of your game object. So even after your enemy is destroyed, it will keep on calling on that kill function. It will still go and call that kill function, but the reference would be null and it will cause errors. So you should always subscribe to that delegate and then remember to unsubscribe. And the best practice is to subscribe on the function void on enable. Here you will write the plus equal to operator, and you unsubscribe it in the void on disable function. This will be covered in more details when we come to the event delegate system. So this is plus equal to subscription and this is minus equal to unsubscribe. This way, even if your game objects are destroyed, the delegate system would still work perfectly. So this was an introduction to delegates. In the next video, I will show you a very good use of delegates, that is how to make callback functions. And in the video after that, I will be talking about the event delegate system, which is a really excellent design pattern used in most of the software and games to make robust and very good event messaging system in your game, which uses delegates extensively.